Hi everyone. In this chapter, we will be talking about the mean, variance, standard deviation, and z-scores. What we will learn about today are the three representative measures for a group of scores. We'll learn how to calculate those, the mean, the median, and the mode. We will use measures of variability to analyze research data. I will teach you how to transform between z-scores and raw scores for a data distribution, and I will show you how to interpret research data using descriptive statistical concepts. So for our first objective, let's calculate the three representative measures of a group of scores. All right, so the first area we're going to talk about are the representative values. A representative value is a single number that describes a group of scores. It usually refers to the middle of a group of scores, and we also call this the central tendency. And it's often the three that we use are the mean, the median, and the mode. We use these symbols, and you'll see these throughout the rest of the course. We use M to mean the mean. We use this symbol called sigma to mean the sum of. We use X to mean the scores or in the distribution of the variable X. Sometimes I'll use Y to refer to scores in the distribution of the variable Y. And then we use the letter N to refer to the number of scores in the distribution. I really like using Excel in my statistical data. And so when you're doing your data in this class, I highly recommend that you use Excel or some other spreadsheet type of software. And what I wanted to show you specifically is in the toolbar, in the ribbon at the top in Excel, you can see that the sigma is right here for creating the sum. This is the sum of. We also see that you can create the average, which I will show you is another word for mean. And there are other ways to use the functions in Excel that can help you to do your calculations for statistics. To me, that's not cheating. That's called using your tools. Okay, so let's talk about how to calculate the mean. Mean is your average of your group of scores, and most of you have done your average in your classes for many years, and so you know how to do this. I just want to show you the statistical way of talking about it, and so it is a sum of scores divided by the number of scores, and so we write this as the letter M for mean, the sum, meaning this is our sigma, sum of scores divided by the N, and the mean is usually the best single number used to describe a group of scores. To calculate the mean, let's say we have these scores in a particular study. You would add these scores up. The total is 84. You would divide them by the number of scores there are, which is 12, and that would give you 7. So the way we would write this is the mean is equal to the sum of the scores divided by N. Sum of the scores is 84 divided by 12 equals 7. The mean is 7. Fairly simple. Now, one of the ways that our book talks about figuring the mean is when you have a distribution. They use an example of talking to 10 different mayors of 10 different cities and talking about the number of years they were in office. So here we have one mayor who was in office for 1 year. So you can see kind of like this is a frequency distribution. We have 2 mayors who were in office for 3 years, 1 mayor in office for 6 years, 2 for 7, 3 for 8 years, and 1 for 9 years. And if you think about it in this frequency, kind of like that frequency distribution like we did in chapter 1, the mean would be the log where you would balance these out. Or you could take each of these numbers. It would be 9 plus 8 plus 8 plus 8 plus 7 plus 7 plus 6 plus 3 plus 3 plus 1. And then you would divide that by 10 and you get 6. So where is the mean? That's where this log is right here. Okay. Now what about the mode? The mode is the most common single value in a distribution. It is the value with the largest frequency in a frequency table. It is the high point or the peak of a distribution's histogram, which is why I have this image of a normal frequency table right here, the graph right here. If the distribution is unimodal and perfectly symmetrical, the mean is the same as the mode. So that means, like in a perfectly balanced world, the mean is equal to the mode. And the usual way of describing the representative value for a nominal variable would be the mode. For example, you wouldn't say that you have 2.5 Catholics. You would, if you were doing like on religion and you said you have this many Baptists and this many Catholics and this many Muslims and this many Buddhists, you wouldn't do an average of that and say, well, you have the average person here is Catholic and you have, 2.5 Catholics. No, because they are nominal. You can't have half a Catholic. So you would have, maybe it would be 3 Catholics. And so that would be the mode that you would use for the nominal type variable. It's very rarely used for numerical variables. So let's go back over here to our, okay, it's not letting me back up. Okay, it's not letting me go back to the mayors. I'll keep going with what I was doing before. So here are the mayors. Here we go. I'll just go forward. So the mode is the high point. So here it shows you that the mode is where you have the most number. And so where is the mode? It is your high point. And so mode for our mayor example is 8. All right, so the other central tendency number that we use is the median. And the median is the middle score. So you line up all your numbers from highest to lowest. And for an even number, you would take the average of the 2 middle scores. And there are simple steps. You line them up. This is just another set of scores. We could use the mayor scores, but you line up all the scores from the lowest to the highest. And then you count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers here. And so once we know, we need to go 1, 2, 3, 4, 5, 6. And since it's an even number, we need to get the 6th and the 7th number, which happen to be 6 and 7. And we take the average of those two. So the median is 6.5. Okay. What is the mode? Can you tell? The mode here would be 6. Because there are 3 6s, 2 8s, and 2 9s, but 6 would be the mode. And the average, you would have to add all of them up and divide by 12. Okay. Now in this set of numbers, the median is right here in between, and it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how about that? The median goes right here between a 7 and a 7, and it would be a 7. Okay. Now sometimes you will have a data set that has outliers. An outlier is an extreme score. So if you have a data set that has an outlier, it makes the average or the mean not very representative of the group. So here are 2 sets of data. 4, 5, 5, 6, 6, 6, 7, 8, 8, 9, 9, and 11. And 11 is the highest. And then we have the same set of numbers, but instead of 11, we have 50. So the median is still 6.5. The mode is still 6, just like before. But look at the difference in the mean for these 2 sets. The mean in the first set is 7. The mean in the second set is 10.25. See how much this 50 throws off the mean in these two? This is that person who got a really high score on a test while everybody else failed. And so it throws off the average. It's not very representative of the whole class if we were to talk about this as a test score. So what happens is the median here becomes much more representative of this sample of data than the mean does. And so when you do have extreme scores, extreme outliers, that's when you use the median. And one of the things that you'll see when you're talking about, when you're looking at data, and you'll see this more often now that you're becoming familiar with it, is you'll see medians when we're talking about income. So when you're reading through the political results, for example, or when you're reading through, let's say that you're looking for a job and you want to see what careers are available to you with the majors that you're looking at right now in your college career, and you look at what is the median income for your career. You're not going to look at the average income, you're going to look at the median income, because some people are going to make extreme amounts of money and others are not going to make so much. Incomes are going to vary too, because it's going to vary depending on where you live in the country, whether you live in a city or in a suburb area. And so when we're looking at income data, we mostly look at median income. So these are some of the measures of central tendency. So how do we use measures of variability? That tells you about the middle. Let's talk about the variability. Variability talks about the spread. So here we have the mean, and we do talk about the mean all the time. It's right here in the middle, right? But the variability can be very different. Look, the range is about the same on these sets of data, but the middle parts, the data is kind of different. So what can happen is that a distribution can have the same mean, but different variability, okay? We can also have data with very different means, but have the same variability. This variability, these look very similar, but the means are different because there's just slight changes in there, but the variability look about the same. So the variability talks about the amount of spread of the scores around the mean, but they tell us different stories about the data set. So the mean is not the only story. We need to know something about the variability. So what we're going to talk about is the variance. I'm going to tell you how to calculate the variance. It's going to be confusing at first. I'm just going to mention the steps, and then I'm going to talk you through each of the steps. So you might want to have this written down on your notes, and certainly once we get to the formula, you'll want to have the formula written down. So variance, the average of the squared difference from the mean. To calculate the variance of a distribution, you will find the deviation score, and I'll show you how to do that. You'll just subtract the mean from each score. Step 2, you'll find the squared deviation score from each score, and that is just, you'll square those deviation scores, so you just multiply it by itself. Step 3, you'll find the sum of the squared deviations, so you'll just add those up, and you'll get the sum of the squares, and then you'll find the average. Okay, and they'll divide those up by the number of scores. So let's look at that. So step 1, we're going to calculate the deviation score. Here we have the list of numbers of years served for our mayors, and we can put this in 2 different columns in the Excel spreadsheet. That's what I like to do. This is taken from a table in our book. We put the mean score, the mean number of years served, in this row, and we just subtract them. So see, they have a subtraction sign, and then we have the deviation score. So for each mayor, we have their deviation from the mean. And you'll notice at the bottom, automatically we can check our work to see if we've done this correctly, because the sum of all of the deviation scores should be 0. It will always be 0. When added together, all deviation scores will equal 0 because they are all going to be the same number of points away from the mean when you add them all together. So it'll be 0. So here we have the number of years divided by 10 is the mean. That's how we get it. We subtract the mean from each of the scores, and then when added together, the deviation scores will be 0. So right now, we have calculated the deviation score for each score in our population or in our set. Okay. Steps 2 and 3 we do together at one time, because what we're going to do is we're going to square the deviation score and then add them together. So if I were doing this in my Excel spreadsheet, I would just start another column and I would multiply this column by itself. So we will, 1 times 1 is 1, 2 times 2 is 4, 2 times 2 is 4, etc. -3 times -3 is a positive 9. -5 times -5 is positive 25. 0 times 0 is 0. 3 times 3 is 9. -3 times -3 is 9. 2 times 2 is 4. And the total is 66. So now we have the sum of the squared deviation scores. When we square the deviation scores, we can then add them together to get a better estimation of the variability of scores. So this is called the sum of the squared deviation scores. X minus M is the deviation score. The sum of the squared deviation scores right here is this symbol right here. So what do you think is the next step? We need to get the variance, and the variance, also called SD squared, which I'll show you in just a minute. We need to find the average of the squared deviations. So 66 is our squared deviation, or the sum of the squared deviations, and so we need to divide that by 10 because there are 10 scores. Okay, so divide that by 10. Our SD squared, or our variance, is 6.6. Now let's talk about that for just a second. The variance is 6.6. Now that does tell us something, but it doesn't tell us quite a lot yet. But you can see that the variance here is similar to the mean, right? It's just another number that is giving us some indication of a descriptor for our data set. So we had the mean, the median, the mode, and now we know the variance. Now let's talk about the standard deviation. The standard deviation is the most widely used way of describing the spread of a group of scores. So we were talking about the variance. We figured the variance is the SD squared. Notice that standard deviation right here is SD. Variance is SD squared. So once we calculate the variance, all we have to do to get the standard deviation is take the square root. So in our previous example with the mayors and the number of years that they had been in office, we had the variance as 6.6. We take the standard deviation, or the square root of that, and now we get the standard deviation is 2.57. The standard deviation will always be the positive square root of the variance, and it is the amount of the average amount that scores differ from the mean. So I was showing you in our last chapter about the normal bell curve and about how the mean is right here in the middle, and then we have the averages going out. So a standard deviation would be the average amount away from the mean. So if the mean is here, okay, so this would be +1 standard deviation away. I can't write on the screen. And here's +2. Okay, woo, yeah, I can't write on the screen. Let me erase those because that's embarrassing. Okay, so that's it. This is 1 away. Let me get my pen back. 1, 2 above the mean, and 1, 2 below the mean. And these are the standard deviations. And so that's what we're talking about when we're talking about standard deviations away from the mean. That's why I keep using the graphic with the bell curve. All right, now let's talk about transforming the z-scores and transforming between z-scores and raw scores. I need to show you how to create a z-score. Let's talk about what the difference is between z-scores and raw scores. Now, a raw score is what we were talking about with the number of years that the mayors had been in office. It's just an ordinary, regular score. They can be very different on different variables. You might get a 3 on one thing and a 72 on something else, and you have no idea what they mean. By themselves, they don't give much information. about their relationship with the rest of the group of scores. And so they're just raw scores. We have to do something to convert them into z-scores to make them more meaningful. A z-score describes a score in terms of how far it is above or below the mean score. And once it is converted to a z-score, it can be compared to other z-scores from other tests so that you can see like how you did on the ACT compared to the SAT, how you did in your math class compared to how you did in your English class. And you can compare them if you're looking at z-scores because you're comparing everything since the means are turned into 0. Once the means are always 0 and the SD is always 1, then you can compare their z-scores. So let me show you how you do that. A z-score is right here. This is our formula for the z-score. So it's your score minus the mean divided by your standard deviation. And that's why we had to calculate your standard deviation. So once you start getting into these calculations, you will see these over and over and over again. You'll see a set of scores. You will automatically get the mean. You will automatically start calculating the standard deviation, and then you'll start getting the scores, z-scores. These are pieces of information that you'll always get with your data. Either you will calculate them yourselves or you will see them in research. Okay, so let's look at the formula for changing a raw score to a z-score. First, you have to figure the deviation score, which I showed you before. You subtract the mean from the raw score, and then you figure the z-score. So we're going to show you how to subtract the mean from the score, and that's your deviation score, and then we're going to divide by the standard deviation. Okay, so let's give an example for this. Let's say that you took a leadership test. The mean on the leadership test is 20. The standard deviation is 3. Your score was a 26. If I just tell you you got a 26 without telling you anything else, you have no idea what that means. Is that good? Is that bad? Who knows? So let's do the calculation. For your z-score, we do the score minus the mean divided by the standard deviation. So 26 minus 20 divided by 3 is 6 divided by 3, or 2. So your z-score is plus 2. Here's the bell curve for this leadership score, okay, for this leadership test. It shows the raw scores up here. So 20 is the mean. We see 23 because the standard deviations are 3, 26, 29. And see right here we have the z-scores. -3, -2, -1, 0, 1, 2, and 3. We have up here the raw scores, 11, 14, 17, 20. Oftentimes you'll see raw scores and z-scores listed together so that it's easy to find where you have the crossover for the score you're looking for. Okay, so where would your score be? You're right here. You are 2 standard deviations above normal. That's a pretty good leadership score. So here I want to show you what happens when you have z-scores for 2 different people and you can compare them. So right here we have the number of times each hour that 2 children spoke. They're shown as raw scores and z-scores. So we have Jacob and Michael. Okay, so right here we have the 0 mark, and that shows you that this is where the mean is. Okay, so the mean for this set of children was 12. Okay, so the average number of times that children spoke per hour was 12 times per hour. But Jacob was below average. Michael was above average. So what does that tell us? Looking at one test score for 2 children, it looks like Jacob is speaking less often than Michael. And Jacob has a z-score of -1. Does this tell us that Jacob is having problems communicating? Does he have a language problem? So by looking at the z-scores, this tells us something might be wrong with Jacob. certainly tells us that Michael is doing well, or at least he's communicating well. But of course, we know that speaking with other children, it could be that Jacob is more introverted and Michael is more extroverted. But we look at these test scores and we want to know more. So I have another test score that I want to show you. So looking at z-scores for time spoken per hour, we look at Jacob's score on the time spoken per hour, and he got a -1, but he was also tested in his language skills. And look at this. He scored a +3 in his z-score on language skills. What does that tell you? When we're looking at both types of scores, we see his z-score here and his z-score here. We can assure the parents of Jacob that because he was reticent to speak, that he was not speaking very often in this testing situation, does not mean that he is poor in language skills. It could be that he might be a little shy. It could be that he is a little introverted. But now we have more information. But just telling them 8 and 100 doesn't give them the information. Z-scores are much more helpful. Okay, now we need to interpret the research data using these descriptive statistical concepts. In research articles, you're not going to see the mean, variance, standard deviation, and z-scores all the time, but you will see half of them. You will see the means and standard deviations more than the variance and the z-scores. The z-scores are helpful when you are looking at your own data, but you'll be reporting the means and standard deviations more often. So let me show you what I'm talking about. When we're talking about variance, one of the things I showed you is that we would be dividing by n, but later on we're going to see that we're going to be dividing by n-1, and that's because we'll be talking about larger populations and we need to make estimations based on that. And so we'll see calculations of variance later on in the class when we're talking about the analysis of variance, which is a much more complex analysis. We'll be doing, I think it's chapter 8 or 9. But one of the things that you'll see when we're looking at research reporting is you will commonly see the means and standard deviations. So remember I told you that we're not going to see the graphs reported out in research data. So you kind of almost have to picture the graphs yourself. So this is a reporting example of Facebook use by university students and non-students. And so we have how much time daily that students spend on Facebook. We have their daily login for Facebook, and then how many friends they have, the photos that they have, and the groups that they are in. So this is for students, this is their mean, and this is their standard deviation, or how far away they are from the mean. And this is for non-students. And so these are the two comparison groups. This is to just kind of get an idea, and this is just a good place to start. You can start to see some differences. Non-students are spending less time. They log in less frequently. They have fewer friends, fewer photos, and they are in fewer groups. Do you see how different that is? And so this is just one of the ways that we look at data. You could also chart this in a graph, but you'll see that in research we mostly list them in tables like this. Here's another set of variables that are posted that are typical for listing in research articles. So something I like to look at are different personality traits that people have. Students versus non-students, again, same type of research done, looking at neuroticism, extroversion, openness, agreeableness, conscientiousness, shyness, narcissism, loneliness, boredom proneness, and self-esteem. So we have the mean right here and their standard deviation. Here we have the non-students and their means and their standard deviation. And so you can see on some of these that they're similar to each other, and on others they're different. And what would be interesting is whether or not we could do any tests to see if there's a significant difference between students and non-students. And that's something that will come up later. All right, thank you for paying attention. I hope that this helps you understand.